all, welcome to another very interesting and amazing chapter, acids, bases and salts. So hope you have very nicely studied chemical reactions and equations, right? Because that chapter is a basic to understand all other chapters in chemistry. Let me start. What is an acid? Okay, what is a base? See, in our lower classes, we studied that acids are sour in taste and bases are bitter in taste. Okay, but you can't give this as a definition here. So this is like one of the property of acids. So basically anything which is acid is sour. Okay, the taste is very it's not pleasant taste. Okay, it's sour. If you can see the citric acid, when you taste the lemon, when you taste the tamarind, how do they taste? They are very sour, isn't it? Because the acids are present in them, natural acids are present in them. And coming to the bases, say when you taste ridge guard, okay, or there are so many vegetables, when you taste them raw, they taste bitter, isn't it? Say when you taste neem leaves, it tastes very much bitter because inside neem leaves there are certain chemicals, they are actually basic in nature. Okay, so that's why it tastes bitter. So anything which is base is a bitter, anything which is acid is a sour. But this is not 100% true. There can be some exceptions also. Do keep that point in a mind. Okay. And now the real definitions of acid and base according to chemistry is explained by three scientists in three different theories, guys. Okay, so there are three scientists which have introduced three theories. So let me write the theories here. So the first one is Arrhenius theory. It is called Arrhenius theory. So Arrhenius is a name of a scientist. So he has given a theory where he said the definitions of acids and bases. So he studied so many compounds and said this is when you call something as acid or this is when you call something as base. So that aspect I'll discuss little later. But he is the first person who actually came and told, if the substance behaves this way, then you can call it as an acid or base. Okay, so we call those definitions and that idea of acids and bases as Arrhenius theory. Okay, and the second person is Bronsted. Okay, so he told some definitions for acids and bases. So we call that as, Bronsted theory. Okay, and third theory was put forwarded by Lewis. Okay, so we have another very important theory called Lewis theory. Okay, so based on the their study of so many compounds, Arrhenius defined acid bases in one way, Bronsted defined acid bases in some other way, and Lewis defined acid bases in a very different way. But whose definitions are correct? Actually all the definitions. Okay, so all are correct. Okay, right? So very important. Say you cannot neglect the definitions given by Arrhenius. You can't neglect the definitions of Bronsted as well as Lewis. All are correct. They are applicable to one or the other different compounds. But here for the 10th standard level, what we teach is the definitions given by Arrhenius. Okay, so now whatever the definitions I am showing you for acid and base, those definitions are given by Arrhenius and that was mentioned in the Arrhenius theory. Okay, so hope you understood how the definitions have come, right? So now I am giving you the definitions of acids. Okay, so acids and bases. So according to Arrhenius, what he said was any substance that gives, okay, substance here means any chemical compound, okay, so any substance that gives H plus ion, very important, H plus ion in water, then that substance is called as a acid, he told. What do you mean by H plus? Guys, what is hydrogen? So hydrogen has a nucleus. Inside the nucleus there is one proton, and outside the nucleus there is one electron revolving. Suppose if you remove this electron, okay, so if you remove this electron, what do you get? You have only the nucleus of hydrogen having one proton. Okay, so actually one proton, if it is freely moving, okay, inside a nucleus, then that is actually called as H plus ion, isn't it? So there is one positive charge, and to neutralize this positive charge there is no electron. So what is extra here? Just one positive charge, right? So that's why this plus charge. So just if you remove electron from hydrogen atom, whatever that one proton left out inside the nucleus, no, that is called as H plus ion, guys. Okay, so any substance in the nature, if it is giving H plus ion in water, then they are called as acids. So according to Arrhenius, guys, substances will not give H plus if they are not put in water. Okay, so here this point is very important. Substance can give H plus only when it is put in water. Okay, so those substances which are giving H plus when they are dissolved or when they are put in water, those substances are called acids. Okay, fine. And now what is a base, guys? So substance that gives OH minus ion in water. Okay, so we know the group OH, right? We call it as hydroxide group, and it carries a negative charge actually, and it is a polyatomic group. Okay, so if any substance is giving a group, right? Which group? OH group. When they are put in water, then those substances are called bases. But you have another definition for base here. So this definition is also very important. So any substance that means which takes H plus ion, is also called as base. Not only the one which is giving OH minus ions, but also the one which is taking H plus from somebody else. Who will give H plus? All that is secondary. Okay, so if something is taking H plus from someone, I mean from some other chemical, then those substances are also called as H plus. Actually this is a Bronsted definition of base here. Whatever the definition I gave, no, second one, that is actually Bronsted definition of base. Anyway, you no need to remember whether something is a Arrhenius definition or Bronsted definition. So that is just for the knowledge I gave you. Just remember the actual definitions of acid. So what you need to know here is just the one which gives H plus in water is called acid. The one which gives OH minus ion in water is a base. And also there is another thing, the one which accepts or takes H plus is also called as base. Okay, so these are the simple definitions of acids and bases. So now let us look at the different types of acids and different types of bases here. Okay, so if you look at acids are divided into two categories. Okay, so one is a strong acid. This is very, very important to understand. And the other one is weak acids. Okay, so strong acids and weak acids. So what do you mean by strong acids? It's very simple, guys. What did I tell you? What is acid? The one which actually if it has to give H plus, it should break in water. Okay, say for example, if you have HCl, say if this guy has to give this H as H plus, first after going into the water, it should break as H and Cl. It should break as H and Cl, isn't it? So this breaking up process, okay, it will break as H plus ion and Cl minus ion actually. So this breaking process, so the way the substance is breaking into two individual ions in water, no, so that breaking process is there, no, that is what we will call it as ionization, because the compound is breaking into ions when you put in water, and this ionization only happens in water here. It only happens where? It only happens in water. Okay, fine. And if a substance, okay, completely breaks in water, if a substance is completely breaks in water, okay, then that substance is called as strong acid. What do you mean by completely breaking? Suppose if you have taken 100 HCl molecules, all 100 HCl molecules are broken into ions in water, then that is called as complete ionization. Okay, so if a substance is undergoing complete ionization, that means how many ever molecules you take, if all the molecules are broken and formed as ion in water, then it is called as complete ionization, and that compound is called as a strong acid. Okay, and weak acid, you know, the substance breaks partially. Okay, so you will expect partial dissociation, okay, or partial ionization. Ionization can also be called as dissociation. Okay, don't worry. So when you observe partial ionization in water, then that substance is called as a weak acid. That means when you take 50 molecules, no, out of 50, when you take 100 molecules, out of 100, if only 50 molecules are broken into ions, remaining 50 molecules, they are not breaking up into ions, they are there as it is. Okay, right? So if only if half of the molecules of total are broken up into ions when they are put in water, then that is called as partial ionization. Okay, so the one which undergoes partial ionization is called as weak acid. The one which undergoes complete ionization, completely if it is breaking into water, how many other molecules you took, that many are completely broken up into water, then it is called as a strong acid. Okay, so this is the meaning of weak acid and strong acid. And what is important here is to remember the examples of strong acid. Okay, examples of strong acid and weak acid. Yeah, this is very, very important, and you need to remember, make a list of examples of strong acid and weak acid. This is very much helpful to understand many concepts that you are going to study further. And if you want to understand the nature of salt, then also this concept will be used a lot. Okay, so careful. Guys, so you must have heard these acids here, HCl, this is the formula. The name of this acid is called as hydrochloric acid. This is called as hydrochloric acid. This is a very, very strong acid, okay. And second one, instead of Cl, if you have Br. Okay, third one, instead of Br, if you have I, you know, what do you call this acid as? Hydrobromic acid. Hydrobromic acid. And this fellow is called as hydroiodic acid. Hydroiodic acid. Okay, so all these acids, HBr, HCl, HI, you know, this category of compounds, behave as very strong acid. That means how much ever compound you take and put it in water, the entire compound will break into hydrogen ion and chlorine ion. Okay, so that's very important. Especially in chemistry, we use this compound a lot. HCl is the compound we use a lot. We don't use this much, and we don't use this also much for the 10th level. Okay, you will see those compounds in the higher classes, 11th and 12th. Fine. And now the fourth one is also very important. See, the important one I will mark with star mark. You should never forget them. Okay. You should never forget that they are strong acids. That's what I meant. Okay. This is important. Now the fourth one which I am mentioning, this is also important. So the fourth one is formula H2SO4, which is called as sulfuric acid. This is sulfuric acid, guys. Okay, and fifth one is also important to remember. The formula is HNO3. Okay, you have to remember along with the formula here. This is called as nitric acid. This is our nitric acid. Okay, and few more acids. Okay, two more acids are there, strong category. I will mention them, but if you just for the knowledge sake you write and keep, no need to remember them. Okay, so first one is HClO3, which is called as chloric acid. We call this as chloric acid. And another one is there, HClO4, guys. It is called perchloric acid. It is perchloric acid. Okay, see guys, there are 7 compounds which are categorized as strong acids. Okay, so all these are very strong acids. So how much ever you take, the entire thing will breaks up to give what ion? Hydrogen ion. See, everything has got hydrogen. This fellow also gives hydrogen. Say here 2 hydrogens are there, hydrogen. See, anything which gives hydrogen as H plus ion is called acid. No, for giving H plus ion, the thing must contain hydrogen. See, all of them have got hydrogen. Okay, fine. And now coming to the examples of weak acids, guys. So weak acid example, the first one very important, which is called with the name acetic acid. Okay, so it is called as acetic acid. Formula is CH3COOH. So many will ask, ma'am, why is the formula like this? Why so many hydrogens and so many long formula they say. But you'll understand why the formula is like this in the chapter carbon and its compound. Okay, so now you just remember the name and formula, acetic acid. Okay, CH3COOH. Second one is formic acid. Of course, you no need to remember. I'll just put a star mark. Whichever formula have shown it as a star mark, no, that if you remember, that's enough. Formic acid. You know this formic acid is present in red ants. Okay, so red ants, the formula is HCOOH. Okay, and the third one, carbonic acid, guys. So H2CO3 we say. Do remember this particular compound, which is called as carbonic acid. Okay, and the final one that I will give for you is HCN, hydrogen cyanide. This is called as hydrogen cyanide, guys. Okay, so these are the weak category acids. Okay, acetic acid. So 2 acids at least you have to remember. One is acetic acid, the other one is carbonic acid. But here at least remember how many acids. HCl you remember, sulfuric acid you remember, nitric acid you remember. Okay, so these 2 also not necessary to remember. And here fifth one also I will give, guys. Do remember that phosphoric acid. Phosphoric acid is also weak acid here. Okay, formula is H3PO4, phosphoric acid. So 3 weak acids and 3 strong acids, at least you should know. Whichever the acids I have mentioned with star mark, they are very important. Strong bases and weak bases, guys. Okay, same thing. What do you mean by a strong base? The one which completely dissociates into ions in water, guys. Okay, so if the complete, how much ever base you took, if everything is dissociating to give OH minus ions, then that compound is called as a strong base. So what is a weak base? If it is not completely dissociating, if it is partially breaking up into ions in water, then it is called as weak base. Okay, so concentrate on the examples. See here, actually you no need to mug up. I am giving you one trick, guys, to remember. Okay, so the trick is first group elements. Okay, so first group and second group elements, when these are with, when they are combined with OH minus ion, then they come under strong base category. Okay, can you I have given you the basics of periodic table in the foundation course, isn't it? So that's very important. Say in the first group, what elements will come? Hydrogen is exception, leave it. Lithium, okay, sodium, potassium, rubidium, cesium will come in the first group. In the second group, what elements will come? In the second group, you will see magnesium, you will see beryllium, right? So beryllium is there, magnesium is there, calcium is there, strontium is there, barium is there. Okay, so these are the elements that come in first group. These are the elements that come in second group. So when these guys are associated with, OH, these guys, when they are present as hydroxides, then all of them are categorized as strong bases. Okay, so for example, sodium hydroxide. How do you write the formula of sodium hydroxide, guys? Sodium in combination with hydroxide. Sodium is Na, hydroxide is OH, no? Sodium valency 1, hydroxide valency also 1. So what is the formula of sodium hydroxide? NaOH. You no need to mention bracket actually. Okay, so sodium hydroxide. Then potassium hydroxide. Okay, then how do you write cesium hydroxide? Cesium hydroxide, right? And now how do you write magnesium hydroxide formula? Magnesium Mg, hydroxide is OH, magnesium valency is 2, hydroxide valency is 2, crisscross method, this 2 will go here, this 1 goes here. So what is the magnesium hydroxide formula? Magnesium hydroxide is MgOH twice. Calcium hydroxide, CaOH twice. Okay, barium hydroxide, BaOH twice. I taught you how to write the molecular formula, right, in the foundation course. See here, potassium, cesium, magnesium, calcium, barium, all of them either come under first group and second group. Okay, right? If first group element is there, OH is single. Okay, only one OH. If second group element is there, OH is double, 2 OHs because of the valency, right? Formula correction is done based on valency. So all these compounds are strong bases. Yeah, remember, you no need to mug up. Just remember this trick. First group and second group containing elements. Okay, so these elements, when they are associated with OH, they become hydroxides. Okay, first group elemental hydroxides, second group element containing hydroxide, all of them come under strong bases category. Okay, so that's very important. Now, weak bases. So just remember, other than these elements, okay, if any other element, say for example silver hydroxide, it is a weak category. Okay, so copper hydroxide, this is also weak. Okay, so other than these elements, if any other element you see with OH, then that comes under weak base category. Okay, super trick, right? So other than first group, second group, you take any element in the periodic table. If you find that with OH, if the formula has got OH along with that element, then those there, whenever OH is there in a formula, you call them as hydroxides generally. Okay, so those compounds come under weak bases. Okay, simple. And along with that, do remember these examples also. Ammonium hydroxide we say. So this is called as ammonium hydroxide. Okay, and the other one is ammonia. So formula for ammonia is NH3, ammonia. So you can ask me, ma'am, this ammonia do not have OH. How can you say it is a base? I gave you one more definition. For that only I gave you one more definition. What is the definition? Anything which accepts H plus can also be called as base, isn't it? So ammonia is categorized as base in that sense. Which sense? This has the ability to accept H plus ion. Okay, so that way ammonia is categorized as a base. Okay, not because it has OH, there is no OH, but still it is categorized as base because this fellow has a capacity to accept H plus ions. That's why it is categorized as base. So guys, first you take this flow chart, copy this flow chart. So we are understanding the chemical properties of acids first, and later we will understand the chemical properties of bases. Okay, so what did I tell you? Acids can undergo 4 major reactions. So they react with 4 major substances, okay, famously. First one is acids reacting with metals. Okay, so reaction of acids reacting with metals. So here we will understand why acid reacts with metals, how they react with metals, what are the examples, what are the limitations here. Everything we are going to discuss under this heading. Okay, so what is the first chemical property that we are going to study in the chapter, guys? Acids reacting with metals. Okay, so second one is acids reacts with metal carbonates and bicarbonates. So these are very special compounds, metal carbonates and metal bicarbonates. Okay, so I will tell you what are metal carbonates and bicarbonates in that specific video. So now you just take down these headings. So the third chemical property is acids reacting with metal oxides. Okay, so there are some substances called metal oxides, and I'll also tell what is metal oxide, what are the different examples. You don't need to mug up anything here, just understand their meaning, you will get the points. Okay, so this is the third one. So this is the second chemical reaction that acids famously undergo. This is third one. And now coming to the fourth one, your acids reacting with bases itself. Okay, so acids and bases are two opposite properties. Okay, acidic property and basic property are opposite. So when chemistry is all about two opposite guys come, react and stay together. Just like how positive charge gets attracted to negative, here positive and negative is just opposite. But when they come together, they get attracted and they stay together. Just like that, chemistry is all about the reaction between two opposite natured substances. Okay, fine. So what are called as, which are metals in the periodic table, guys? So actually speaking, group 1 elements, okay, and group 2 elements. So these elements are the most metallic elements. Actually till group 13 all elements have got metallic property. Okay, but group 1 and group 2 elements are pure metals. They are actual metals. Okay, so what are group 1 elements? Leave hydrogen. Hydrogen is exception, guys. So you forget about hydrogen. Okay, so here comes lithium, sodium, potassium, rubidium, cesium. And here comes beryllium, magnesium, calcium, strontium and barium. Guys, so these are called as metals. So why do we call something as a metal? anything that has ability to lose electrons. Okay, so usually anything, okay, that means any element. So anything in the sense it should be some element. Okay, so the element which has ability to lose electrons is called metals. So this is the actual definition of metals, guys. Okay, right? So anything which has the ability to lose electron is called metals, and such metals can very nicely react with acids. Okay, so acids actually very violently reacts with metals here. And guys, whenever metals, okay, you take any of the metals when added to any acid, okay, so they give product like salt and hydrogen gas. You take whatever the metal it is, make it react with whatever the acid it is, you'll always get salt and hydrogen gas. You know what? This is a kind of displacement reaction only. Okay, so it is a type of metals reacting with acid is there? No. This is a type of displacement reaction only. Okay, so here, how it is displacement reaction? Observe here. Observe, guys. You all know reactivity series, isn't it? So if I have to write the reactivity series, what is the shortcut trick to remember the reactivity series? Please stop calling me careless zebra. Instead, try learning how copper saves gold, isn't it? So please here means potassium. Okay, please stop. That is sodium. Stop means sodium. Please stop calling me. So that is calcium. Okay, magnesium, aluminium, isn't it? Please stop calling me a zebra. So that means Zn, zinc. Okay, instead that means iron, Fe. Try, that means tin. Okay, instead try learning, that is lead, Pb, and hydrogen, copper, silver, gold, isn't it? So this is the reactivity series that you have studied. I already told about this in the first chapter. And look at the position of hydrogen, guys. So many people will say, ma'am, hydrogen is not even a metal. No, how come you place in the reactivity series? Reactivity series is only for metals. Scientists have studied all the metals, and based on the reactivity, based on the reactions, based on their power, they have arranged all the metals in the decreasing order of the reactivity. Okay. Metal which is coming above, metal which is placed above is always more reactive than the metals that are coming under that element. Okay, so that means potassium is more reactive than sodium, sodium is more reactive than calcium. Okay, like that. So the metal which is at the bottom is always less reactive than the metal which is there on top. Okay, so that is the concept. So here all are metals, but many people worry about this hydrogen. Hydrogen, how come it is a metal? Guys, hydrogen is a very special element. Okay, sometimes the behavior of hydrogen is just similar to the metals, and sometimes the behavior of hydrogen is similar to non-metals. So it has some metallic property and it has some non-metallic property also. Okay, so and there is a reason actually why hydrogen is placed here in the reactivity series. So you will find hydrogen in the reactivity series. Okay, so now the metals which are there above hydrogen, everything, all these metals which are there above hydrogen, they react with acids very easily. They react with acids, no doubt. They react with acids. Okay, because look the reaction. Suppose I have taken zinc. Okay, so I have added to HCl. Okay, so what will happen? This zinc is more reactive. Okay, so this is more reactive more reactive than hydrogen. Okay, you should not compare with chlorine. Chlorine is a non-metal. Okay, so in the reactivity series, zinc is coming, hydrogen is coming. So this guy is more reactive than hydrogen. So zinc is coming in the place of hydrogen. So this zinc is there, no? This is coming in the place of hydrogen. Any acid, it will have hydrogen, isn't it? Because the substance that gives H plus ions is what we call it as acid. To give H plus ion, it should have hydrogen. So acids definitely will have hydrogen. So when you react with a metal, you know, if the metal is coming above, okay, in the reactivity series, above hydrogen in the reactivity series, definitely they will occupy the place of hydrogen. Okay, so hydrogen will come out. Okay, so zinc is going in the place of H. So what do you get? Zinc chloride, ZnCl. This is not the formula. Now when you write the formula, you have to check valency. That's very important. What is the valency of zinc? 2. What is the valency of Cl? 1. So this 2 goes there. So the formula of zinc chloride is ZnCl2. Okay. So, okay, zinc is coming in the place of hydrogen. So I'll write Zn. Here only 1 Cl is there. So 1 Cl, I'll call it as zinc chloride. Wrong. So whenever you write a formula, you are correcting the formula based on valency only. Okay, so it's very important. Now hydrogen. Hydrogen is coming out as hydrogen gas. Always when hydrogen is supposed to present single, you know, it is always present in the form of a molecule. Okay, hydrogen cannot exist as H. It can be present as H plus. That's a different thing. This and this, lot of difference is there. Okay, so this H cannot present single. Okay, right? So this H is always present, you know, in the molecule form. So whenever you write hydrogen single, you have to write it in the form of a molecule. That's very, very important. Okay, so now you have to balance the equation. That's it. So 1 zinc, 1 zinc. 1 hydrogen, 2 hydrogen. So what you will do, you will put 2 here. Okay, so now the equation is balanced. So this is the example for, you know, metal reacting with acid. So I took zinc as a example for metal, HCl as an example for acid. So isn't it a displacement reaction? Definitely, right? So guys, since the metal is more reactive than hydrogen, the metal is coming in the place of hydrogen, and that's how you are getting hydrogen gas. And how do you know that the gas is hydrogen? Okay, so how do you test this? This also is very important question. How do you test hydrogen gas? How do you test? How do you test the presence of hydrogen gas? Okay, say suppose you have taken a test tube. So you have taken HCl liquid, which is an acid. From outside you have added zinc metal. You know what? You'll observe some gas coming out. Okay, and how do you know that this is a hydrogen gas? You have to do some testing, no? So that's what I'm talking about. So guys, when you keep a burning candle near a gas, so when burning candle, okay, when burning candle is kept near H2 gas, you know, it burns the gas. This H2 gas is there, no? This will burn with pop sound. It burns with pop sound. Pop sound means what? Dup sound. Okay, you must have seen the crackers. Okay, how they burn. They burn with dup sound, isn't it? So that's what we will call it as pop sound. Okay, so hydrogen gas, when it is burning with pop sound, you know, a gas burning with pop sound is confirmed to be a hydrogen gas here. Okay, so that is all about the concept here. So the concept is very simple. Any metal that is coming above hydrogen in the reactivity series, only those metals can react with acids. Acids, you can use anything here. Here I took HCl as an example for acid. You can take H2SO4 also. Suppose if you have taken H2SO4, what is the product you will get? Zinc and H2SO4 I will add. So what do you get? Definitely zinc will go in the place of hydrogen. Okay, so what do you get? Zinc SO4. Check the formula. Zinc valency 2, sulfate valency is also 2. So when 2 is there, it get cancelled. So formula can be ZnSO4. And this hydrogen will come out as H2. You no need to balance this reaction. It's already balanced, isn't it? So this is what the salt that you get. And many people think that salt means it is only NaCl. No. Okay. No, guys. Let me tell you, when do you call a substance as salt? When metal, okay, you take any metal, when it is there in combination with metal, in combination with, if metal is there in combination with non-metal, okay, with non-metal like chlorine, okay, bromine, iodine, fluorine, you call them as salt. Okay, and when metal in combination with sulfate group, you call them as metal. Okay, sorry, you call them as salt. For example, see, sodium sulfate, right? Zinc sulfate. So sodium, zinc, what are they? Metals. So they are there in combination with sulfate. So anything, calcium sulfate, right? So all these, when metal is there in combination with sulfate, you call them as salt only. Okay, and likewise, see here, metal in combination with non-metal like chlorine, bromine, that means Na in combination with Cl, NaCl, NaBr, okay, KCl, K is also metal, like this. Okay, and also metal in combination with carbonate group, you all know, like calcium carbonate, okay, sodium carbonate, formula Na2CO3, like this. Okay, not only that, metal in combination with nitrate also, nitrate. Okay, that means sodium nitrate, NaNO3 is the best example. Okay, lead nitrate, PbNO3 twice, right? So number 1, number 2, number 3, number 4. So these conditions, so whenever you have a substance or a molecule, in the molecule, if you carefully observe, like one side metal is there, some metal, what are metals? Like you all know, group 1 to group 13, all elements more or less they are called as metals. Okay, but group 1, group 2 elements I have shown here, no, in the previous page. Yes, group 1, group 2 elements are strong metals. Okay, so guys, so whenever you see a molecular formula where you have one side metal, the other side non-metals like these guys, one side metal and the group like SO4, so one side metal, on the other side the group like CO3, one side metal and the other side the group like NO3. Okay, so I call them, the SO4 containing substances are called sulfates, CO3 containing substances are called carbonates, NO3 containing substances are called nitrates. Okay, so what are these guys? What are these guys called? Sulfates, metal sulfates. Okay, they are called as metal sulfates, and these guys are called metal carbonates. These guys are called metal carbonates. Metal in combination with carbonate is metal carbonates. Metal in combination with sulfate is metal sulfates. So these are called metal sulfates. Okay, understand, this is a very much basic, very important to understand, metal carbonates, and these guys are called metal nitrates. Metal nitrates. Okay, so metal sulfates, metal carbonates, metal nitrates, metal halides, these are called halogens, no? So they are generally called as metal halides. Metal can be anything, halogen atom can be anything. Okay, so metal halides. So these four categories of chemical substances are called salts. Okay, so salt means not always NaCl. Salt means metal halides, any metal halide, any metal sulfate, metal can be anything if it is there in combination with SO4 group. metal carbonates and metal nitrates. So all these guys, all these categories are called salt. So now we look at here what category this particular example belong to. Zinc is a metal, sulfate. So this comes under an example of metal sulfate. Okay, so usually whenever a metal reacts with an acid, you will get one or the other salt depending on what acid and what metal has reacted, and you get one or the other salt along with that hydrogen gas. Coming to the reaction of acids with metal carbonates and bicarbonates here. Okay, many people get confused to write the product for this reaction, but let me tell you with logic and common sense. First, let us understand what actually we mean by metal carbonates and bicarbonates. Okay, so very simple here. Metal when it is there in combination with carbonate group, we know the polyatomic group, carbonate group, CO3 group. Okay, and metal in combination with bicarbonate group, metal with bicarbonate group. So what do you mean by bicarbonate group? It is HCO3 group is called bicarbonate group. Okay, its valency is -2 and its valency is -1. Okay, so I told you what is carbonate group and its valency. So now you take any metal, you combine with this and write it as a formula. It becomes a metal carbonate example. Okay, suppose if the metal is sodium. Okay, I have combined with CO3. What is the formula of sodium? It's called sodium carbonate. What is the valency of sodium? 1. What is the valency of carbonate? 1. So formula is correct. So when both are 1 and 1, you no need to indicate in a bracket. You can indicate the formula as NaCO3. This is also fine. So now let me write. So what is this? Sodium carbonate. So now let me write the formula for calcium carbonate. Calcium carbonate. Okay, so calcium, metal calcium. Okay, carbonate is CO3. Calcium valency 2, carbonate valency is also 2. So 2 gets cancelled. So what is the formula? CaCO3. Okay, say sodium carbonate, calcium carbonate, you can write magnesium carbonate. What is the formula? MgCO3. Barium carbonate, BaCO3. Potassium carbonate, K2CO3. Yes or no? Yes, here carbonate valency is 2, no? So sodium carbonate formula has to be Na2CO3. Right? So K2CO3 is potassium carbonate. Okay. So bicarbonates, similarly, sodium bicarbonate, how do you write the formula? NaHCO3. Sodium valency 1, bicarbonate valency 1. So this is a formula. Calcium bicarbonate, how do you write? CaHCO3 twice. Why this 2 has come here? Because calcium valency 2, bicarbonate valency 1. So this 2 goes here and this 1 goes here. Isn't it? So this is the formula of calcium bicarbonate. So any metal, if it is there with this group, you call them as bicarbonates, and any metal, if it is there with this group, you call them as carbonates. Okay, so hope you understood what exactly we mean by metal carbonates and metal bicarbonates, right? And very important point here is these metal carbonates and bicarbonates are there, no? What are they? They are a type of salts. I told you, no? What is a salt? Any metal when it is in combination with CO3. Metal in combination with, what is that? NO3. Metal in combination with SO4. Metal in combination with halide like chlorine, bromine, iodine. All of them are called as salts, isn't it? So these are also kind of salts because metal is there in combination with carbonate and metal is there in combination with bicarbonate. Bicarbonate combination also salt category only. Fine. And in the previous video I told salts are of different nature. They have different characters. Some can behave like acid. Such a salt is acidic salt. Some salts which behave like a base can be called as basic salt. Some salt which doesn't behave like an acid nor base, they are neutral salt. Okay, so here metal carbonates and bicarbonates are basic salt. What type of salts? They are basic salt. Since they come under basic salt, they behave like bases. They behave like bases, yeah. So they have a basic nature. So they have They have basic nature. Nature means here character. Okay, so in chemistry, whenever we say this has this nature, that nature, it means character. So it has a basic nature or basic character. The way the bases react, with whom the bases react, these guys also react in a similar way. Okay, so since they are basic, can't they react with acid? Yes or no? Okay, so mention your opinion in the comment section. Yes, since these guys are basic, chemistry is all about two opposite things come together and react. These guys have a basic character. With whom are they reacting? Acids. Obviously, they react with acids. And can you tell me what kind of reaction is this? Acid reacting with a basic guy. It is a type of neutralization only. Many people get confused. It is a displacement reaction. No guys, this is a type of. It is a type of neutralization only. It is a type of neutralization reaction, guys, because an acid is reacting with a basic. This is not exactly a base, but base-like compound. Okay, it is not exactly like a base, but it is a copy of base. It behaves like a base which is not exactly a base. Okay, so guys, acid is there, base like compound is there. So what are the products you will get? Definitely you will get salt and water as the product. So guys, whenever acids, I'm writing a logic here, whenever acids react with metal carbonates and bicarbonates, react with metal carbonates and metal bicarbonates, write this, very important. What are the products you will get? You will definitely get some salt, you will definitely get some water, because it is a type of neutralization. We discussed neutralization in the previous class. Any acidic thing reacts with a basic thing, you will always get salt and water as a product, and we know how to write the product also. Okay, so here also you will get salt and water, but along with that, one more gas is formed as a product, that is carbon dioxide. Why carbon dioxide, ma'am, if you ask? Because the carbonate, you have this group, CO3 group, no? So that group somehow it comes out in the form of carbon dioxide also. So guys, this is the logic of this reaction. So whenever you take any acid, you take any metal carbonate or bicarbonate, you will always get a salt. The formula of a salt depends on what type of metal carbonate has reacted with what type of acid. But this water and carbon dioxide is a common byproduct of the reaction. So very, very important. So water and carbon dioxide are common byproducts, guys. Okay, only the type of salt varies, and that depends on the type of metal carbonate reacted with the type of acid. Right? So now we will write the chemical equations for this. So hope you understood, it's a type of neutralization reaction. It is not a displacement reaction, because many students get confused with this. They think that it is, they write the product based on displacement or something. Sodium is more reactive. So if I take sodium carbonate, okay, if I take sodium carbonate as an example and I treat with HCl, many people think sodium replaces hydrogen here, that's how you will get a salt. No, okay, it is a type of neutralization. So this fellow is acid. This is base like, it is not base exactly, it is a base like substance. So obviously you will get a salt and water as the product. Isn't it? So what is the salt you will get? What is the salt you will get? Definitely negative guy of this would react with the positive guy of this. That's what makes a salt, no? So what is the salt you will get? Definitely NaCl. And now H here, Okay, so H and too many H's would be there because you will not use one HCl, many HCl you will use. H and O of this would combine somehow and you will get H2O, and this carbon and oxygens are remaining and that also have to be come out as a product, so you get carbon dioxide. Okay, so water and carbon dioxide is common. Okay, what type of salt you get depends on what type of carbonate you took and what type of acid you took. Similarly, if I have to write a reaction with bicarbonate, say let me take sodium bicarbonate. Okay, so here also same thing, this is a negative guy and this is a positive guy. So you write the salt formula. Okay, later just mention water is compulsory product, carbon dioxide is compulsory product. Okay, so this is how. Now balance the equation, that's very important. So 2 sodiums here, here only 1, so I'll put 2. So when I put 2 here, yes, chlorines, 1 chlorine, 2 chlorine, so I'll put 2 here. So now I'll see hydrogens, 2 hydrogens, 2 hydrogens balanced, 1 carbon balanced, 3 oxygens, 2 plus 1, 3 oxygens balanced. And what about this equation? It's already there in a balanced form. You can check it. 1 Na, 1 Cl, 1 plus 1, 2 hydrogens all together this side, 2 hydrogens, 1 C, 3 O's, 2 plus 1, 3 O's all together this side. Okay, so this is how you will write the equations. Okay, say questions can be asked very differently. Say they'll ask a question. So in your NCERT also question is there. So when dilute hydrochloric acid, is added to crushed eggshells, okay, what happens? Write the reaction. So you have to write the equation. What happens? Always in a chemistry, for any question, chemical reaction is what you have to write. That too in a balanced form. Very, very important. Okay. See here, crushed eggshells contain calcium carbonate. Okay, so that outer part of an egg, when you boil the egg shell that you peel off, no, that's actually calcium carbonate. You should know this. Okay, so calcium carbonate. So you have a calcium carbonate and you have added acid. So it is like an acid reacting with metal carbonate. This is an example of metal carbonate, isn't it? So how do you write the reaction? Acid, HCl. And how does it react with calcium carbonate? So definitely you will get salt, water and carbon dioxide. Water, carbon dioxide is compulsory product. What is the salt you will write? Negative guy of this, positive guy of this. So calcium chloride. Check the formula based on the valency. Calcium valency 2, chlorine valency 1. So calcium chloride formula is CaCl2. Okay, later you have to balance the equation. That's it. 1 calcium, 1 carbon, 2 Cl, only 1 Cl. So I'll put 2 here. The moment I put 2 here, everything will get balanced. Okay, so this is how the questions can be asked indirectly. Okay, so dilute HCl is added to crushed eggshells. What is the product? What happens? Write the balanced chemical equation. So this is how the questions can be asked. Yes, so now we understood how acids are reacting with metal carbonates and bicarbonates and how you are getting salts, water, carbon dioxide. And for any acid, for any metal carbonate you take, you need to know how to write the products. That's very, very important. Okay, now let me go to the concept here. Testing carbon dioxide gas. Testing carbon dioxide gas. So actually speaking guys, say you take some acid or you take sodium carbonate in a beaker or test tube. You keep adding acid. Acid can be any acid you can add. Okay. So carbon dioxide gas will come out in the form of bubbles. Okay. Say it will ooze out like a volcano. Okay. So from a volcano, how the fire, lava comes out, no? Like that. carbon dioxide gas oozes out in the form of bubbles, and that is called as brisk effervescence. Brisk effervescence. Remember this word also. You can witness this in the next video where I have shown this experimentally. Okay, so carbon dioxide, just like you take a Sprite, Coca-Cola or Thumbs Up. Okay, you shake it properly. When you open the cap, the gas comes outside, oozes out, isn't it? So that's a carbon dioxide. That's how the carbon dioxide comes out from a solution, if it is there. Okay, so carbon dioxide is formed from a solution, it is oozing out like a bubbles, and that is called brisk effervescence. Okay, brisk effervescence. And now, how do you know that this is a carbon dioxide gas? How do you test? What is the proof for saying that this brisk effervescence is a carbon dioxide gas? So there are two ways of testing. One is a simple one. Okay, keep a burning candle near it. Keep a burning candle. Keep a burning candle. What would happen? Fire extinguishes. Fire extinguishes. In the sense, the flame gets stopped. Candle flame gets off. Okay, so that's why in the fire extinguishers, carbon dioxide gas is actually used to stop the fire. Okay, to off the fire, right? So this is one way you can test the presence of carbon dioxide. If you keep a burning candle near hydrogen gas, it burns with more sound. But when you keep a burning candle near carbon dioxide gas, the flame gets off. Okay, so that is one way. And the other way is by doing some chemical test called lime water test. Lime water test, and this is very, very important. Okay, so we do a chemical test. We make the gas pass to lime water. Okay, I'll tell you what is this lime water. There happens a change in the lime water. By observing that change, one can come to know that it is a carbon dioxide gas. Okay, so let us now study about this lime water test. Okay, so lime water test is used for testing the presence of carbon dioxide. So what is the importance of this lime water test? It is used for testing the presence of carbon dioxide. So very, very important test. So even in the higher classes you will use this test in the practicals. Okay, whenever you want to see whether the gas is carbon dioxide or not, chemically, what chemical test you will use? This lime water test. So now let us understand about the lime water test, how we actually do. Before we understand about test, you should know what is lime water. Lime water is nothing but a solution of, calcium hydroxide. It is a solution of calcium hydroxide, guys. Okay, so that means what is the formula for lime water? It is just calcium hydroxide solution. This is the formula for lime water. Okay, fine. Now, what I will do is, look over here. Let me open your NCERT textbook where they have shown it diagrammatically. Okay, look at this figure, guys. Look at this activity 2.5. Okay, so let me just I'll zoom out the figure only. Okay, yes. See, here they took a test tube. Okay, so in a test tube they took sodium carbonate. So sodium carbonate they took, and they have added dilute HCl also. So here dilute HCl plus sodium carbonate is there. Obviously you will observe carbon dioxide gas oozing out. Okay, so what gas is this? So carbon dioxide gas is coming out in the form of brisk effervescence, and that gas they are passing it to another test tube. And here what is there? Calcium hydroxide is there. So we are purposefully passing carbon dioxide to lime water. So what would happen? So here carbon dioxide gas is passed where? Passed to calcium hydroxide solution. So what is the chemical reaction that happens? Let us write. Calcium hydroxide when reacts with carbon dioxide, you know guys, usually this calcium, this is a positive part, and carbon dioxide, you know, it's a negative guy. So calcium reacts with carbon dioxide to form calcium carbonate. Yeah, along with that this hydrogen and oxygen will come out as water. Okay, and this calcium carbonate, okay, will form as milky white precipitate. Okay, so the moment calcium carbonate is formed, okay, the moment carbon dioxide reacted with calcium hydroxide, what is formed? Calcium carbonate. No, you will observe that milky white substance, that is calcium carbonate. So this is formed here. This is formed as the carbon dioxide is continuously reacting with this fellow, that is calcium hydroxide. You will slowly observe that white milky substance is formed. That's nothing but calcium carbonate. If this milky substance you will observe in the second test tube, it confirms the presence of carbon dioxide, because carbon dioxide alone can react with this fellow to give milky white, that is calcium carbonate. Calcium carbonate is a limestone. Okay, so limestone is nothing but calcium carbonate. What color does it exist? White, solid. Okay, so white solid keeps on forming as long as you pass carbon dioxide to calcium hydroxide. Okay, so if you observe the formation of this white milky precipitate, then it confirms the presence of carbon dioxide. Okay, and now actually guys, this reaction is what, you know, this reaction whatever I wrote here, this is what we will call it as lime water test. Lime water test. Okay, see nicely, whatever the carbon dioxide they get, that from this tube it is going to another test tube. In this another test tube, what is there? Calcium hydroxide. So if you observe white color getting formed, that white color thing is nothing but what? Calcium carbonate. Okay, if that is formed, yes, confirm the gas that is coming out here is carbon dioxide, because this when passed to this only you get this particular compound. Okay, so this experiment I have beautifully explained in the next video. Watch that experiment, okay, where I have shown it live, how carbon dioxide comes out, how to pass to another test tube and etc. Okay, and now another concept here. So we know lime water. So what is a lime water test? Calcium hydroxide, to this fellow when you pass carbon dioxide, you will get calcium carbonate along with that water. So this is that white color substance. To this white colored substance guys, okay, what is there in a test tube now? What is there in a test tube now? After reaction, what is there in a test tube? Calcium carbonate and water is there. And if I keep on passing more and more carbon dioxide, so if I pass excess carbon dioxide, then this thing is there, no, this calcium carbonate plus water thing, that gets converted into calcium bicarbonate, yeah, and this calcium bicarbonate is colorless solution. It is a colorless solution. Okay, so when excess carbon dioxide is passed to the same solution, once the in a test tube, once the calcium carbonate is formed, but still you are supplying more and more carbon dioxide, what would happen? That white color thing will disappear. Okay, so what is happening here? White color disappears. White color disappears. So why white color is disappearing? Because this colorless solution is formed. Okay, because calcium bicarbonate is formed and calcium bicarbonate is colorless. Calcium carbonate is white. As long as calcium carbonate is there here, that white color stays. Once it has converted to calcium bicarbonate, why does white color remain? It will disappear, no? Because the color of this fellow is colorless. Okay, it doesn't have any color in a solution. Okay, but it will have white color in a solution. It doesn't have any color. So when more and more carbon dioxide you kept on passing to this calcium carbonate which is already formed, then you have a chances of this getting converted into what substance? Calcium bicarbonate. And what is the color of calcium bicarbonate? Colorless. Okay, so they might ask you a conceptual question. Why is when excess CO2 is passed, excess means more. Okay, when excess CO2 is passed, why is the white color disappearing? They'll ask you. You have to write this chemical equation. You have to tell, because the carbon dioxide, calcium carbonate is getting converted into calcium bicarbonate, whereas calcium bicarbonate is colorless in a solution form. Okay, so that is all about this lime water test, guys. Okay, so now that's all. The same activity here, that's what they are asking. If you look at this activity, take two test tubes, label A and B, take sodium carbonate in a test tube A and sodium bicarbonate in test tube B, add dilute HCl. See, what do you observe? What do you observe? Brisk effervescence you will observe, right? Pass the gas produced in each case through lime water. So when that gas is passed to lime water, what do you observe? This white color, milky substance you will observe. And again more and more carbon dioxide is passed, that white color turns up into colorless because this compound is formed. This compound is getting converted into this compound. Okay, so that's all about the activity and the concept here. How acids actually react with metal oxides. Guys, this is also a kind of neutralization reaction only. Even it is a type of neutralization reaction. Okay, right? So let me tell you how it is a kind of neutralization reaction. So you have to understand what actually we mean by metal oxides here, right? Say simple, metal, some strong metal in combination with oxygen becomes metal oxide. Say for example sodium, when you combine with oxygen, what do you get? Make proper with the help of valency, make the formula proper with the help of valency. Sodium valency 1, oxygen valency 2. So what is the formula of sodium oxide? Na2O. K2O, potassium oxide. Magnesium oxide, MgO. Valency of magnesium is 2, oxygen is 2. So 2 gets cancelled, MgO. Calcium oxide, quicklime, you have seen, this is called as quicklime, right? So all these are examples of metal oxides. Okay, and metal oxides are basic in nature. Okay, so they have what property? They have basic property. Just like I told you in the previous video, sodium carbonates or metal carbonates or metal bicarbonates, they are basic, I told. Because they are basic, they can able to react with acids. Because a chemical reaction is all about a reaction between two opposite charactered substances. Okay, right? So guys, these guys, metal oxides are always basic. Okay, so always remember metal oxides are basic, whereas non-metal oxides, for example, what are non-metal oxides? Carbon dioxide. Carbon is a non-metal. Nitrogen dioxide, sulfur dioxide. See, all these guys, carbon, nitrogen, sulfur, all these are non-metals, isn't it? So, non-metallic oxides are always acidic, guys. Okay, in fact, just understand a basic concept that any compound with metal, okay, so you have metals, right? So what are metals? Group 1 to group 13 elements, okay, whichever elements that come under group 1 and group 1 to group 13, they are generally called as metals. Okay, so their compounds, so in any chemical compound, if this element is there as a major element, then their compounds are always basic. Okay, so you take sodium. any compound of sodium you take, okay, say it can be a sodium oxide, or it can be a sodium hydroxide, okay, say any compound that contains sodium, most of the time it is basic, especially the oxides and hydroxides, no, okay, when the metals are present with oxygen and hydroxide, most of the time if metal is there as a major element, then those compounds are always basic in nature. Similarly, non-metals. So what elements are called as non-metals? Group 15 elements, group 16 elements and group 17 elements are majorly called as non-metals. Group 15 nitrogen, phosphorus, all those. Group 16 oxygen, sulfur. Group 17 fluorine, chlorine, bromine and etc. Right? So guys, these guys oxides and these guys, okay, compounds of these guys, majorly oxides, okay, so their compounds, you know, their compounds are acidic in nature. Their compounds are acidic, guys. Okay, so this is a logic in chemistry. Okay, so the elements which you find in the left side, that means group 1, group 2, group 3, their compounds, if any chemical substance that contains those elements as a major element, they always behave as bases. They have that basic character. Okay, so non-metals, 15 group, 16 group, 17 group, if those elements are there as a major element, especially the oxide form, okay, so they are acidic in nature. Okay, so this is a thumb rule in chemistry that you can just note it down and learn it. Okay, so now, like I told you in the previous page, like your metal oxides, since metal is the major element here, you know, this is going to be basic in nature. So when something is a base, it can easily react with acid. That is the thing that we have studied so far, isn't it? So when acid is there, when this fellow reacts with metal oxide, and this metal oxide, what character it has got? It has got basic character. Obviously, when an acid is reacting with a base, you will get salt and water. So here also, the products that you get is salt and water, guys. You will get a kind of a salt. Again, the formula of a salt depends on what metal oxide you took and what acid you took. Okay, so based on that you get a particular salt, along with that water is a common thing. Okay, see, let's see the example. See, I have taken HCl, okay, and I have taken copper oxide. So many people say, ma'am, HCl doesn't react with copper oxide because copper is less reactive than hydrogen. Guys, this is not a displacement reaction. It is a kind of neutralization reaction. This is where many students get confused. Okay, see, copper oxide, it is an oxide. It has got basic character, and this fellow is acid. So you cannot apply displacement reaction whenever you want. Okay, so this is a kind of neutralization reaction. So what would happen? So positive guy is this H, negative guy is this oxygen. So H and O combines to form water. So what is left out? Negative guy from this fellow and positive guy from this fellow, copper chloride. Copper valency 2, chlorine valency 1. So what is the formula of copper chloride? CuCl2. Okay, so it is CuCl2. And usually copper oxide color, guys, it is a black color that you have observed in the chapter 1, right? So this is usually to this black colored substance, when you add HCl, no, you know, the black color gets converted into blue-green color solution. Blue-green solution you get. That indicates the formation of copper chloride, guys. Okay, so color change can indicate that there is a chemical reaction happening, right? So here the reactant was black in color, and slowly when you add HCl to this, slowly it gets converted into blue-green solution. Okay, so this is there in your textbook. Color change also try to remember. This is important. Okay, and you can write any example, any acid you take, guys. Say for example, I'm taking H2SO4. Okay, and I will take what oxide? Sodium oxide. I'll take any metal oxide you take. Okay, so what is the product I get? Definitely this H and this O would combine to give H2O, and what is left out? Sodium and sulfate. So what is the formula of sodium sulfate? Na2SO4. See, this is the salt you are getting, okay, along with that H2O. So like this you can write n number of examples. Okay, so you should know the logic, you should know. It's not that you have to by heart only the equations which are mentioned in NCERT. Out of something like this also they can ask you. Okay, so you should not get panic. Oh, this reaction is not there in NCERT, so they won't ask in the exam. Not like that. Concept is there, no? Yes, concept is there. You should be ready enough to write the answers for whatever the acid they give and whatever the metal oxide they give. So let me give some more equations as an example. Take it as a homework and mention the answer in the comment section. I want everyone to mention answer for these questions in the comment section. Whoever is watching the video, you have to mention the answers in the comment section. Okay, so the first one, let me take HCl. Okay, and I have calcium oxide. So what is the product? You have to fill the gap here. Okay, and the other one, I'll take H2SO4. Okay, and I will add to magnesium oxide. So what is the product? So what is the product you will get? Here also two products, right? So mention the answer in the comment section. So this is all about reaction of acids with metal oxides. So now how acids are reacting with bases. Guys, chemistry is all about a reaction between two opposite characters. Okay, see, we all know a negative charge always attracts a positive charge, right? Two opposite things will always get attracted. Same thing here. Okay, two opposite chemicals with different characters. Here opposite chemicals in the sense two chemicals with different characters, opposite characters always like to combine and stay together. Okay, so that's what is the crux and logic of chemistry here. So here acids have one character and bases exactly have opposite character. They behave oppositely as that of acid. So obviously we can expect a reaction between acids and bases, isn't it? And these reactions are called with the special name called neutralization reaction. Okay, so neutralization reaction, very important. This can be directly asked in the exam, like what is neutralization reaction? Okay, so what is neutralization reaction? The reaction between acids and bases is called neutralization reaction. Okay, so now let us understand what happens when acids and bases react. What products are you going to get? Okay, is a big question mark. So very simple, guys. Say let me take an acid. So whenever it reacts with a base, you will always get the product one or the other type of salt. Along with that you will get water. Okay, so this is what is called neutralization reaction. So a reaction between acid and base to give salt and water is called neutralization reaction. So this is what the definition you can use to write in the exams. Okay, fine. And now, so how are you getting salts here? So I told you in the previous video, salt means not just NaCl. Halides, metal in combination with halogens, metal in combination with the CO3 group, metal in combination with NO3 group, metal in combination with SO4 group. So all of them come under salt category only. Okay, so now here very famous example for acid, we all know HCl. So let me take HCl only as an example for acid. And the famous example for base that we kept on studying is NaOH, right? So here, guys, what actually happens is every chemical, like every formula, usually have something as a positive charge and something as a negative charge. Some positive part would be there in that and some negative part would be there in that. Okay, so here H is a positive part. When H is a positive part, obviously Cl has to be negative part. Okay, so usually in a formula, when you write formula, no, you write formula with the combination of two elements, isn't it? So the first written element, majority of the times it is a positive guy. So the next written element, majority of the time it is a negative guy. Okay, so it can be an element or it can be a group like this. This is not an element, this is a polyatomic group, isn't it? So the first written element, the first guy, the first part of the formula is always a positive guy and the next part of the formula is always a negative guy. Okay, right? So simple guys. Positive guy of this fellow would like to combine with the negative guy of another chemical. Okay, and the negative guy of the first chemical would like to combine with the positive guy of the next chemical. That is what is the crux of chemical reaction, yaar. Okay, you no need to mug up how to write the product. This is what the logic we use to write many of the reactions. Most of the reactions you can write product based on this aspect. Okay, no problem, you will get correct. So at least the main product that you are supposed to get will be correct. The byproduct sometimes can go variation, right? So now see here, hope you understood. Let me repeat once again. Any chemical will have a positive part and negative part. Okay, so positive part of one formula, I mean positive part of one compound would like to attack with the negative guy of another compound, whereas the negative guy of this compound is attacking the positive part of another compound. So what do you get as a product here? See here, the acid positive part is H plus, in the base the negative part is OH minus. So both of them are reacting with each other, both of them would like to combine with each other. So H plus and OH minus, H and OH if I combine, what do I get? Water. Okay, so you will always get water here. No matter what acid you take, no matter what base you take, you will always get water as one of the product in neutralization reaction, because the logic is very simple. Anything that you call as an acid will definitely have H plus. Anything that you call as a base, most of the time it will have OH minus. So in a base, that OH is a negative guy, and in an acid that H is a positive guy, and both of them has to react. So one of the product you always get in these reactions is water, guys. Okay, so that is how you are getting water. Now what else is remaining? So the Cl minus here and Na plus here. So Na and Cl will combine. So sodium chloride you get. What is the formula? Na and Cl. Again, you have to see whether the formula is correct or not with the help of valency. So here Na valency is 1, Cl valency is also 1. So the formula NaCl is correct. Okay, so this is the best example for neutralization reaction. Okay, fine. And now all the neutralization reactions are exothermic in nature. Okay, so that means heat is released during the reaction. Heat is released. So when the moment you add acid to a base, you will see the reaction mixture getting hot. That means within a reaction, suddenly the heat will get released. Okay, so such reactions are called exothermic, isn't it? So this point is very, very, very important, guys. All neutralization reactions are exothermic. They would ask you like give reason question. Why neutralization reactions are exothermic? So what should be the answer? They release heat. Okay, during neutralization reaction, heat is released. That's why they are exothermic. They are said to be exothermic. Dilution is nothing but addition of water to an acid solution or basic solution. So what would happen during dilution? The concentration of H plus ions in case of acid and OH minus ions in case of base decreases. That means the number of H plus or OHs per unit volume always decreases when you keep on adding water to acid solution or basic solution. So that was the concept we have discussed. Now if I ask you a question, say you have learned strong acids and weak acid, isn't it? Suppose I give you two solutions for you. Okay, so this is a solution 1 and this is a solution 2. And I have acids, different acids. Okay, so let me take this as acid 1 and this as acid 2. Okay, so both are colorless and both look in a similar way. But my question to you is, how do you find out which is a strong acid and which is a weak acid? If you use litmus paper, okay, or if you use phenolphthalein or methyl orange, whatever it is, both of them will convert blue litmus to red. Both of them would give red color when methyl orange is added. Both of them remain colorless when phenolphthalein is added, isn't it? So those indicators are useful to find out whether something is acid or base. But now I am asking you, how do you differentiate between strong acid and weak acid? Or if I have two bases, okay, so this is a base 1 and this is a base 2, and I'll ask you to find out which is a stronger base out of two, to differentiate strong acid or weak acid. Or if you want to differentiate between strong base and weak base, then we use something called pH. So pH is always written like this, small p and capital H. I'll tell you its meaning little later. Okay, so this pH concept, when do you use it? So it is used to differentiate, to differentiate between strong and weak acids or bases. Okay, say we have something called universal indicator. Okay, right? So here just like the litmus paper, okay, just like the litmus indicator, we have something called universal indicator here, right? So very, very important to understand about this universal indicator. So what is universal indicator? How is it extracted? Nothing. This is just a mixture of many indicators. Okay, so they will mix many indicators, mixture of many indicators, many different natural or artificial indicators. Okay, what indicators they will mix? None of your business. Okay, we don't want here. Just understand this is a mixture of so many different indicators. Okay, so by mixing all of them, you will get some indicator called universal indicator. So we quote this universal indicator on a paper. Okay, so just like litmus solution, how you coated onto a paper and how you got red litmus paper and blue litmus paper, no? In a similar way, this universal indicator is coated on some paper, and that paper is called pH paper. It is called pH paper. pH paper looks in slight orange or yellow color. Okay, it looks slightly yellow. So slightly yellow, slightly orange color paper. Okay, just like you have blue litmus paper, red litmus paper, no? Similar to that, you have this slightly yellowish shaded paper. Okay, say actually you can order it in Amazon. Say because next I am going to give you an activity for you all to try at home, okay, where for that you need this pH paper, this universal indicator papers and etc. You can get all of them from Amazon. You can just book and buy it, okay. So I don't think it is too much costly. It can be available for a very reasonable prices, like say 100 or 150. I recommend you to order that pH kit, okay, for yourself, because we are going to do amazing activities, okay, out of that. Fine. So now, hope you understood this much. So universal indicator is a mixture of so many indicators. It's a solution, and that solution is coated on paper, and that paper is called pH paper. How does it look? It looks slightly yellow in color. Okay, fine. And this pH paper, okay, changes its color. It actually changes its color at different H plus ion concentration, at different H plus ion or OH minus ion concentration. Okay, so this is the concept here. Right? Say we all know HCl is a strong acid, it will have more H plus ions, isn't it? And acetic acid, that is CH3COOH, is a weak acid, it will have less H plus ion, right? So HCl, when you dip this pH paper in HCl, you get a particular color. When you dip this pH paper in acetic acid, you get another color. Okay, so looking at the color change, okay, identifying a color, one can able to differentiate between strong acid and weak acid. Similarly, you can differentiate between strong base and weak base based on the color change of which pH paper. Okay, so that is the concept. Hope you you have understood this concept, right? If you have understood this concept, say understood in the comment section. Okay, right? Super. Now, how do you know, like how do you compare the color? Okay, if you get a color red, what does it mean? If you get a color green, what does it mean? If you get a color blue, what does it mean? If you get a color orange, what does it mean? Because on dipping this pH paper into different solutions, you get different colors depending on the concentration of H plus ions. Okay, if the concentration of H plus ions is more, if you have too many H plus ions in a solution, if it is such a strong acid, you might get dark red. If the solution is moderate, okay, medium concentration if it has got, you will get different color. If the solution has got very less number of H plus ions, you get a different color. So how do you know? You need to have some comparison aspect, right? To identify the colors, to compare the colors, right? So what is the meaning behind these colors? Yes, you can check a color and you can compare the colors with something called, you know, pH reference paper. pH, there is something called pH reference paper. Okay, so where this is a paper with different colors. Okay, this is a paper with different color. Let me show it. It is mentioned in your NCERT textbook also. Let me open your textbook here. Yes, look over here. Let me zoom it. This is what we call pH reference paper. Okay, so you have numbers from 0 to 13 and you will have till 14, okay, right? So guys, look over here, right? See, this is a red shade, dark red in color, right? See guys, in a particular solution, when you dip, you know, universal indicator paper, okay, so if the color is changed to, say you're dipping into this, if the color is changed into red color, okay, so let me say just take a pen here. If it has changed to red color, say I dipped into this solution, so this part of a litmus paper has changed. Okay, pH paper has changed to red color. So then you will compare this color with this reference paper. So you will have a reference paper with different colors. Okay, so red color. So how does it look like? Dark red? No, it is looking something like this. So the pH is 0 to 1. So the pH value will lie between 0 to 1. That is what the meaning, guys. Okay, so different solution, the paper's color changes in a different way depending on the concentration of H plus ions and OH minus ions. Okay, so now that color you will compare with this reference paper. Okay, say if the color is blue in color, say again you have 3 shades of blue, isn't it? So light blue, medium blue and the dark blue. So based on that you can pick up the pH value. So all these are pH values, 0, 1, 2, 3, 4, all these are called as pH values. Okay, so there is a scale called pH scale. Okay, so we call it as a pH scale. Okay, those pH scale is what do you mean by a scale here? It means range. Okay, so there is a pH range. So 0 to 14 is the pH range. Okay, so now if you get a pH value 7, okay, so the pH value 7 in the sense the solution is neutral, it is neither acidic nor basic. So that is what the meaning of the pH 7. Okay, so let us see now. So this is pH 0 to 14. pH value is equal to 7 means what? The solution is neutral. Okay, neutral in the sense it is neither acidic nor basic. That is what the meaning. Now if the pH values are below 7, okay, so if your colors, when you dip a pH paper, if the colors are red shades or yellow shades, light green shades, then it means the pH value is below 7. So below 7 means it is acidic in nature. The solutions are acidic in nature. Lesser the pH value, more is the acidic nature. More is acidic nature. This is very, very important. Okay, say suppose I'll ask you a question something like this. These questions are very, very common. So I have a solution A with the pH 2, I have a solution B with the pH 5. Which is more acidic, they will ask you. So here, lesser the pH, more is the acidic nature. Actually both are acids only because the values are below 7, isn't it? Right? But among them which is more acidic? Lesser the value, more is the acidic. Okay, so actually speaking, pH, P means power, okay, H means hydrogen ion concentration, hydrogen ion concentration. Okay, so using the concept of pH, we are measuring, okay, hydrogen ion concentration, whether the hydrogen ions are more or moderate or less. This is what we are measuring with the concept of pH. So that's why the full form power. P means potence. Potence is the Greek word which is nothing but a power. So P means power, H means hydrogen ion concentration. So we are measuring hydrogen ion concentration here. So when the pH values are below 7, it is indicated that they are more acidic solutions. Okay, so lesser the pH value, lesser the number, more is the acidic nature. Okay, fine. So now if you get a value above 7, okay, till 14, if your values are lying between 7 and 14, so if the values are above 7, then they are considered as basic solutions. Okay, so they are basic. So now here, higher the pH value, more is the basic nature. Higher the pH value, so this is very, very important. Higher the pH, more is basic nature or basic character. Okay, yeah. So suppose I have a question, solution A has got a pH 9, solution B has got a pH 13. So I'll ask you which is more basic. So here what you should do, the value which is greater is considered as more basic. That means it has got more OH minus ions. Okay, right? So this is what the meaning behind the pH values that you should know. So if you get a pH value 7, it means it's a neutral, neither acidic nor basic. If the values are below 7, they are acidic. If the values are above 7, they are considered as basic. And again, in below 7, lesser the pH value, more is the acidic character, stronger is the acid. More is the acidic means what? Strongest is the acid. Okay, higher the pH value, higher means what? Higher numbers, 13, 12, 14, those values. So higher the pH value, more is the basic nature. That means that particular solution is strong base. That's what the meaning. Okay, so hope you understood this. See, here we discuss about the importance of pH in different areas. Okay, say coming to our body liquids. Okay, biological liquids I can say, or the liquids which are present in our body. So what are the liquids that you observe in a body? Majorly blood, and you have lymph, and you have many liquids actually. Okay, so all these things contain so many compounds, isn't it? So those compounds, say proteins, enzymes, everything will flow through blood only, hormones, and all of them are different chemical substances. So when you talk about a chemical substance, they either can have a acidic behavior or basic character, or they can remain neutral. Okay, so that actually gives pH for a liquid. Okay, so the pH of a blood actually dependent on what components are there in a blood, right? What is flowing in a blood? What actually is there in a blood? What is the nature of those components? All that will decide the pH of blood. So usually the blood will have a pH range of 7.4 to 7.8 here. So this is the pH range of blood. Okay. And this pH range is very important in our body. Okay, so usually almost all the liquids inside a body can have this pH range. So most of the chemical reactions do happen at this pH range only. So if pH becomes more or less, that can be a disturbance in a body which leads to some other diseases, yeah. Right? Say you must have observed people say when you buy cosmetics and put it on a skin, let the pH be 5 to 7. The pH has to be slightly acidic. Only then it works on a skin. It can be safe on a skin. It should not be too much acidic. It should not be basic. Right? Say everything works on certain pH. Every chemical reaction in fact works on certain pH inside our body. Okay, so pH is very important. If pH is disturbed inside a body, those chemical reactions which are happening inside may also get disturbed, and that leads to one or the other disease or disturbance inside a body. Okay, so pH of a blood should be there in this range. Okay, and here we study a concept of rain water's pH. Okay, rain water usually, the normal rain water will have a pH almost approximately equal to 7. It should be neutral. When the rain water's pH is neutral, then it is safe. But if the rain water's pH falls below 5.6, right? Below 5.6. Let me check the actual number from your NCERT book itself. Okay, let me open your NCERT book. 5.6. Okay, so if the rainwater's pH is 5.6, then such a rain is called as acid rain. Okay, very dangerous. So imagine 5.6 pH for a rain, right? Such a rain, if it falls on a skin, okay, or on monuments like Taj Mahal and etc., what would happen? They will spoil. We get skin allergies. And what if this rain gets mixed up with rivers and oceans? Inside a river you have a life, isn't it? So you have this aquatic life. See here, when acid rain flows into the rivers, it lowers the pH of a river water. Yes, the pH of river water also decreases. That water also becomes acidic. Lowers pH means what? It's becoming more and more acidic. As the pH value is lesser and lesser, more is the acidic nature. So obviously the river water's pH also becomes more and more acidic. So the survival of aquatic life in such rivers becomes very, very difficult. Okay, so very important. Now the question is, how come the rainwater's pH all of a sudden becomes 5.6 is the question, isn't it? So very simple. The answer is very simple. It is due to pollution. Due to pollution here. Okay, say nowadays we have lot of industries releasing the gases, very dangerous gases such as NO2, SO2, SO3. You know, these gases are very dangerous. You know what? Your NO2 on mixing with water, this NO2 would become HNO3. Yes, imagine in the atmosphere if there is NO2 gas, rain is coming out from cloud, that rain on reacting with NO2 which is there in the atmosphere in the middle, right? What it is getting converted into HNO3. So HNO3 is falling down onto the skin. That's why the pH has become 5.6. Actually it should be neutral. How the value got decreased? It's because all of a sudden in between NO2 is there, our water is reacting with that and the compound is becoming HNO3. Similarly, SO2 and SO3, no, they on combination with H2O, that gets converted into what acid, guys? Sulfuric acid, yeah. What if sulfuric acid falls on a skin? Right? So the skin will get spoiled, it will get affected, aquatic life will get affected, plant life will get affected, the wonderful monuments such as Taj Mahal, Gol Gumbaz, you know, all these will get affected, right? So actually the acid rain is not the pure H2O, it is these acids that are falling, because in the middle, in the atmosphere, what is happening? Your gases are there, these gases are there in the atmosphere due to pollution, due to industries and etc. They are actually combining with the water that is coming from clouds, and in the way, I mean, you know, the things have got converted into acids and that is falling out, and such a rain is what we call acid rain. Okay, so obviously it will have the pH range lesser than 7, that is 5.6, which is a very dangerous call. Okay, so this is one aspect that you should know. We can't live in Mars, we can't live in Venus, isn't it? So there the atmospheres are not suitable for life. That's why we don't have any life in other planets in this solar system. We have life only in Earth. Okay, so why we will not find life in Venus? One of the reason is in Venus the atmosphere is made up of sulfuric acid. The atmosphere is not made up of safe gases like oxygen, nitrogen and hydrogen. The atmosphere is made up of what acid, guys? It is made up of very dangerous acid, that is sulfuric acid. So that's why that is one of the reason why life is not there on Venus. Okay, and now I will put you one question. Why life is not there in Mars? You tell me. There is a very strong reason why life is not available on Mars. So you comment the answer in the comment section, or you tell me the answer in the next inner circle call. Okay, fine. So that is one aspect. And now let us discuss about pH in agriculture here. So this is very important. See, you must have observed, right? In some areas only certain crops can be grown. Say in my area, the area where I live, we grow paddy. We don't grow coffee or tea. Coffee or tea, it will not come in our area. But our area soil is very good and it is suitable for paddy, it is suitable for sugarcane, okay, it is suitable for groundnuts, suitable for cotton. Okay, but our area soil is not suitable for coffee, tea. It is not suitable for areca nut. Okay, it is not suitable for coconut. Why is this? Soil is soil only, no? Why? In some areas you can only grow certain crops. It depends on pH here. Okay, see in my area, the pH, basically the soil's pH is slightly acidic. Okay, we have a acidic soil in our area. So the acidic pH is more suitable for the growth of paddy, sugarcane, cotton, etc. Okay, whereas to grow coffee and tea, acidic soil is not suitable. Maybe the basic soil can be suitable. Okay, right? So, depending on the soil's pH, one must select the suitable crop. Only then you will get the yield. And sometimes, you know what? They will add the fertilizer to the soil, right? Say suppose in my area, like in my home, I am very much willing to grow coffee, but the soil is not favorable for the growth of coffee. What I can do, I want to make my soil basic. Okay, so I want to grow coffee. For that I should make my soil basic. Okay, for this only I can add fertilizers. I can add fertilizers that contains basic compounds. I can add fertilizers that contain basic compounds like calcium oxide. I can add calcium oxide is a basic oxide. So I'll mix my soil with little bit of calcium oxide. So the soil becomes slightly basic, and then I can expect coffee to be grown in my soil, right? Like that, you know, sometimes we mix the soil with different fertilizers. Okay, it is to make the pH changes. Okay, if I want basic soil, I'll add basis as fertilizer to my soil. If I want acidic soil, then I can add some acidic guys to the soil to make the soil acidic, okay, for the yield of my crop. So this is how the pH plays a very important role even in the agriculture. Okay, so you can test the pH of your soil. I told you in the previous video, if possible you can place an order of pH paper kit, right? So if you have that pH paper kit at your home, you can try this activity here. You can just take some soil, you know, add some water, allow the soil to settle. Okay, you get that transparent liquid. To that you just dip pH paper and see the color change. Later that color you match with the reference paper, you will get to know what is the pH value. Okay, at least you can get to know whether your area soil is acidic or basic, right? So you can test. So this is one fun activity that you can do it on your own interest. So that is about the pH of soil, and this is very important in agriculture. Okay, so now let us talk about the pH, how the pH is very important in digestive system. Okay, so like I already told you guys, we have already discussed in the life process chapter that, you know what, our stomach produces an acid, HCl. So why is this HCl important? This HCl is important for digestion of proteins. Because if you want to digest protein, okay, you need an enzyme called pepsin, and that pepsin works only in the acidic environment. So the pH value inside our stomach is below 7. It's always below 7. Okay, and you know the pH can be 3 or 2 or 1 because HCl is a very strong acid. Okay, so we can call it as a gastric juice also. Okay, so that pepsin and HCl combination and other enzymes, other chemical combination is called gastric juice. So the gastric juice is highly acidic in nature, so the value can go up to 1 also, below 1 also. Okay, fine. So highly acidic thing we have. And this pH range and this acid is very much essential for the digestion of proteins, you all know it. But when you consume spicy food, okay, spicy food, or when you consume some hard food, I mean the hard food in the sense the food that is very difficult to digest, okay, you know what, production of HCl increases. HCl production increases. Okay, so the stomach produces more and more HCl. When more and more HCl is produced, that leads to a condition called acidity. It leads to a slight condition, okay, unfavorable condition, okay, called acidity. So this is a very common problem in every household. Okay, you can ask your parents, you can see your grandparents suffering with this acidity. So it is all because of, you know, overproduction of acid. Some acid, yes, necessary for the digestion of protein, but if it is overly produced, if it is produced too much, okay, then is a problem. So that leads to the irritation in the stomach, pain in the stomach, pain in the chest, okay, and finally it can lead to stomach ulcers also. So if you don't treat this condition, it can lead to stomach ulcers, even stomach cancer also, right? So that is the extent. But of course, those are all some dangerous calls. But the very basic condition initially that you observe is acidity. Okay, so that is what we mean by acidity. Now, how do you prevent this acidity? I mean, like, how do you treat this acidity? How is acidity caused? Because of the overproduction of acid. Okay, if you consume bases, what if you consume bases? That acid can get neutralized, no? So that overproduced HCl gets neutralized. Then the problem is solved, right? So if the HCl is getting neutralized, then the problem is solved. Okay, that is how we treat acidity. Okay, so we consume bases, and those bases, what are the examples? You know, we don't consume all the bases. There are specific bases that should suit for a body. It should be safe for a body, right? So usually magnesium hydroxide. So this fellow only can be called as milk of magnesia. This itself is called as milk of magnesia, guys. Right? So magnesium hydroxide, and even sodium bicarbonate sometimes, okay, so which we will call it as baking soda. So baking soda is commonly available in every household, right? So we put that in cakes, breads, idli, dosa, you know, that baking soda, it's a mild base. Even sometimes this is used, and you must have observed ENO, yes. So you might have seen your parents and grandparents taking this ENO. So you see the ingredient that is there in ENO, it is a base. Okay, tell me the ingredient that is there in a base. You all have to type that ingredient in the comment section. Okay, so we will discuss about that ingredient in the inner circle call. Okay, so all these guys are bases that can neutralize overproduced HCl. Okay, and these guys, these bases which have neutralized, you know, overproduced HCl is called with the word antacids. They are called with the word antacids. So they'll ask in the exam, what is antacids? Antacids are the medicine which are used to treat acidity. How is acidity caused? They'll ask you. Acidity is caused due to overproduction of HCl. Okay, so, and what other examples are given in your textbook? Okay, say what other examples they gave? Milk of magnesia, that is magnesium hydroxide. Only magnesium hydroxide they gave as an example, but you still remember all of them. Okay, so even aluminium hydroxide also. Okay, I'll give you one more example. Aluminium hydroxide also they will use. Okay, so usually that pink color syrup bottles, if you have in your houses, just look the ingredients. Sometimes it's a mixture of magnesium hydroxide and aluminium hydroxide actually. Okay, so it can be a MgOH twice, or a baking soda or aluminum hydroxide. All these are categorized as antacids. So this is one aspect that you should know. That is all about pH in our digestive system. So now let us go for pH in mouth. So what is the reason for tooth decay? Guys, how many of your tooth got decayed? How many of you have tooth issues? I think 80% of you will have tooth issues. Nowadays, dentist is earning lot of money because everybody in a house has tooth issues, right from child to old person. Okay, everybody has tooth issues. It is all because of our food style. It is all because we don't know how to maintain our oral health. Oral health in the sense mouth health. Okay, right? So let us discuss about this tooth decay. How is it caused? This is one of the very important question. How is tooth decay caused? Okay, right? Very famous question in the boards. See, when pH of a mouth falls below 5.5, okay, so if the pH of a mouth is below 5.5, okay, so look at here, tooth decay starts when the pH of a mouth lowers than 5.5. This is where the tooth decay starts. And the question is, how does the pH becomes 5.5? How pH becomes 5.5 is the question. So very simple, guys. Okay, so let me tell you that in the next page. So this is your tooth, right? So you have tooth like this. So when you eat, food particles will get stuck in between the tooth, right? Imagine night you ate nice food, you didn't wash your mouth. Okay, you slept like that only, where 90% of us do not brush our teeth before we sleep, right? Okay, so after eating food we sleep the whole night. The food particles get stuck between the tooth. So that leads to the development of more and more bacteria. So it is a festival for bacteria because bacteria has now got too much food for them. Okay, so it is a feast for bacteria. So these bacteria will feed on the food that is stuck in between the tooth. Okay, and you know what, some chemical process happens inside the bacteria with food, because inside the bacteria also digestion will happen. So it consumes the food and digestion should happen inside the bacteria, and as a output, as a byproduct, bacteria releases acid. Okay, so after the digestion of food inside a bacteria releases acid as a byproduct. You know what, we release carbon dioxide as a byproduct after respiration, no? But bacteria releases few acids after it consumes food. Okay, so this acid spoils tooth enamel. Okay, so tooth has a protecting layer. Okay, so that protective layer is called tooth enamel, which is nothing but calcium phosphate. Okay, so calcium phosphate, what is the formula? Ca3PO4 twice. So this tooth enamel or tooth covering is made up of this chemical, calcium phosphate. So the acid that is released, that will eat all the calcium phosphate. Okay, it will remove all the calcium phosphate. That means it will remove all the enamel. So when the tooth enamel is lost, that is the stage where the tooth will get spoiled. Actually, the tooth enamel is protecting your tooth, but because of the acid produced, the pH will decrease below 5.5, and at that condition, all your tooth enamel will go away. That hardest material, actually calcium phosphate is one of the hardest material, okay, and that hardest material is being eaten up by the bacteria indirectly. Okay, because eaten up by bacteria in the sense spoiled by bacteria. right? So that is the reason why the pH is getting decreased to 5.5. Okay, so that condition, that spoiling of tooth enamel and slowly bacteria eating up the skin between the tooth, okay, is what we will call it as tooth decay. Okay, right? So now how do you prevent this tooth decay? Definitely. So one is, see, because of too much acid in a mouth, no, tooth decay is causing. So you brush your teeth, brush teeth using some bases, using basic compounds. Okay. See, the toothpaste. Usually you will brush your teeth with toothpaste, isn't it? And this toothpaste has got basic compounds. You can look at the ingredients behind the toothpaste. You will find sodium lauryl, something like that. Okay, sodium they will mention in the ingredient, some sodium containing thing. Sodium containing things are always basic in nature. Okay, and also fluoride. So this fluoride is also the one which can neutralize the acid that is produced inside the mouth. Okay, so how do you prevent tooth decay? One is by brushing teeth, okay, regularly with the help of toothpaste. The other one is just washing your mouth after eating. So whenever you eat something, whenever you consume something, you will have to wash your teeth nicely, swirl and wash your teeth with water, so that most of the food particles that got stuck in between the tooth will get washed away, so that you can be safe from too much of bacteria. Okay, so that is all about this concept. And coming to the next concept, self-defense by animals and plants through chemical warfare. Have you ever experienced a bite from honeybee? Yes, I think most of you have experienced bite from honeybee, right? It's actually the sting, the sting of honeybee. It will release an acid called methanoic acid. Methanoic acid can also be called with the pet name formic acid. So formic acid is like a pet name for methanoic acid. Okay, so this acid gets released into the skin when it bites. Okay, it sting, whatever the honeybee has, it actually injects this particular acid onto your skin. So wherever it injects that acid, no, that area swells, okay, and it becomes red, and you will experience pain because it has released that particular acid onto your skin. And how do you overcome the pain? How do you decrease that redness? How do you decrease that swelling of a skin? You can do that. It is the acid, right? If it can get neutralized, the symptoms will get over. Okay, you can get rid of the symptoms if you can neutralize this acid that just got injected onto the skin. How do you neutralize? You can neutralize with some bases. You can neutralize with bases, definitely. Have you ever observed at your houses, whenever honeybee bites, some people will rub toothpaste onto the skin, or some people will apply the paste of baking soda. Why do you think they apply baking soda paste or toothpaste? Because they are basic in nature. Yes or no? Just now we have discussed toothpaste has got basic compound. Similarly, baking soda is sodium bicarbonate, which is a basic compound. So when you rub that basic compound onto a skin wherever honeybee bite is there, that acid which is there in that area will get neutralized, so that you can get relieved from pain, inflammation, redness, swelling, etc. Okay, so that is the logic here. And few people rub with the soil also, because if the soil is basic, then it will work out. If the soil is also acidic, it will not work out actually. Okay, so all these home remedies have got some meaning, isn't it? Okay, so that's all about this particular aspect. And now if you look at the next page, look at here, even some plants, okay, some wild plants, which these leaves are called nettle leaves. Okay, so nettle leaves, and these nettle leaves also have slight thorns, okay, at their margins. Even this particular thorns also can inject that formic acid or methanoic acid into the skin. Okay, so you'll observe the same kind of redness and swelling that you have observed when honeybee stung injects that formic acid. Okay, so the nettle leaves also can inject what kind of acid? It will inject, you know, methanoic acid. Now another aspect that I would like to tell you is this particular table in NCERT is very very important, guys. Okay, so where did it go? Yeah, this table. Okay, so this can be asked as 1 mark question, or they can frame it as a MCQ also. Okay, so which compound has got what acid? Vinegar. Okay, so vinegar has acetic acid, orange has citric acid, tamarind has got tartaric acid, tomato has got oxalic acid, milk or curd has got lactic acid, lemon again citric acid, ant sting and nettle sting, both of them have got what acid? Methanoic acid. So what source has got what acid is very important. Okay, so that is all about the concept. So now we will also finish off these questions, whatever is there, simple questions here. See, you have two solutions A and B. Okay, the pH of a solution A is 6, pH of a solution B is 8. Which solution has got more hydrogen ion concentration? Obviously, lesser the number, lesser the pH, more is the acidic nature, no? So this fellow has got more H plus ion concentration. Okay, fine. Now what else they have asked you? Which of this is acidic and which one is basic? Obviously more H plus ions means more acidic. So this is acidic, and here the pH value is above 7. Obviously this is going to be a basic compound. Super. Now the second question. Let me zoom out. What effect does the concentration of H plus ions have on the nature of solution? Okay, say definitely if H plus ions are more, okay, are more, then pH is less. pH is less in the sense what? Below 7, isn't it? So lesser the pH, more is the H plus ion concentration. So that is what the effect here. So what is your answer? Lesser the pH, it indicates more H plus ion concentration. Okay, so this can be the answer, right? Yes. Next, do basic solutions also have H plus ions? If yes, then why are these basic? Guys, very interesting question actually. Okay, actually basic solution also has H plus. I'll tell you how. Okay, see, a base is a base only in presence of a water, no? Only in presence of a water a base can give OH minus, right? So now whenever you dissolve a base in water, you know, it becomes a basic solution. And you know, this water has H plus ions. Say inside a water, sometimes water can be present as H plus and OH minus ions too. Okay, so this H2O is there, no? Sometimes the H2O can be present as H plus ions and OH minus ion. That means where are these H plus ions are there? Basic solution. So basic solution, Say the base has OH minus. So here OH minuses are there and H plus ions are also there, but OH minus ions are more than H plus. These guys are more than H plus. Okay, right? So you have very less number of H pluses from water. Okay, compared to H plus ions, which is a part of water, the OH minus ions presence is more. Okay, so that's why since there are more OH minus ions, H plus ions, even if they are there, they are negligible. Okay, so that's why what is the answer? Do basic solutions have H plus ions? Yes, because aqueous, see, they have mentioned in the bracket aqueous. Aqueous means what? You made the solution with the help of water. Water obviously have some H pluses. Okay, because water molecule can be present in the form of H plus and OH minuses also. Okay, so you will observe few H pluses, but they are coming from water, not from base. Okay, but base, what ions they have? OH minus. So here the number of OHs are much greater than H pluses. So you will have more OH minus ions as compared to H plus. So that's the reason they are basic. So then why they are basic, they asked to know. So what is the answer? Number of OH minus ions. Okay, that means you can write like this. Number means what? Concentration. Concentration of OH minus ions is much greater than H plus ions. H plus ions. Okay, so that's very, very important. So that's why they have given AQ in the bracket. That means water. So when you mix base with water, do they have H pluses? Though it is a basic solution. Yes. Where did that H plus have come from? Maybe from water. But then why do you call as a base? Because OHs are more predominant. They are much more in number as compared to H plus. Okay, so hope you are clear with this question, where most of them will get confused with this question and they come and ask me. Okay, so you should be very, very thorough with this. If you are thorough and understood this question, say understood in the comment section. Okay, and coming to the last question. Under what soil condition do you think a farmer would treat the soil of his field with quicklime? Quicklime in the sense what? Calcium oxide. And understand what is the nature of calcium oxide basics. So tell me, why is he adding this calcium oxide to his soil? Maybe he wanted to make soil basic. He wanted to make soil basic. That means what must have been the nature of that particular soil? The soil must have been acidic. Okay, so the soil must have been more acidic, but he don't want the soil to be so much acidic for the crop that he is growing. So he must have added, the quicklime to the soil to make it maybe neutral, or maybe to make it more basic. Okay, so what is the condition? Why did he add? If he has added calcium oxide means, then obviously the condition of the soil must have been either acidic or neutral. Maybe he wanted to bring that soil to a basic condition for his crop. That's the reason he added these bases, calcium oxide and calcium hydroxide. Okay, so or chalk, that is calcium carbonate. You know what? Let me go to the next bit. Okay, chalk piece. Okay, limestone, marble, all of them are calcium carbonate only. Okay, all these are different forms of calcium carbonate. So whenever a question has a word chalk or limestone or marble, fix that the formula for them is calcium carbonate. They are talking about calcium carbonate. It's a basic salt, basic compound. Okay, so that is all about the importance of pH in everyday life. So in the next video we are going to discuss the very important topic, salts. That too, the different kinds of salts I will teach you.